Hi there, welcome back. Okay, this next session, which I haven't got up yet, is going to be all about networking, mobile services and authentication. I love talking about this stuff, so I've got this like 3 hours of content I've had to cut down to 45 minutes, which is tragic, frankly, but there's loads of real cool stuff, and so I'm going to get straight into it because I have got a lot to talk about. Networking basics, what everybody should know and thinking about networking. I'm then going to do a nice demo showing the great tools we've got in Visual Studio for working with Azure Mobile Services. Then have a quick look at background transfer service, down to the HTTP client if you need to really get down and make direct HTTP calls, and then going to wrap this one up with looking at authentication. Specifically, well, a little mention of credential locker, which we looked at yesterday because it's relevant to this context. But what this is really about is the web authentication broker. So, the first one of them, the basics about networking. Okay, the thing is, and like this is like, really, you're telling me this? Mobile devices are not always connected. Now, it's worth mentioning this. People forget this, even though everybody uses mobile devices and everybody knows that you haven't always got good Wi-Fi, you haven't always got a good cellular signal. You know, so you have to remember about this when you're building apps, and also app developers spend their whole time probably doing software development on PCs that have probably got a pretty good network connection because you set yourself up in an office with that and you cannot work without a good network connection. And you're kind of building software on an emulator and you forget that when it's actually being used, you may not have a good network connection. And although mobile networks are getting faster, you know, 4G is being rolled out, LTE, and it's all really cool, the reality is that that high-speed connectivity is only available in pockets here and there. And if you live in, like, the mountains, like I do in North Wales, well, if you get a real fast network connection, that's a rarity. So enjoy it while you've got it. But you need to build apps that work well, if they need a network, that work well in a wide variety of network conditions. And you've got to think about the costs of using those networks as well. A lot of users obviously are very cost sensitive in terms of the amount of data that's going across the networks and how much money it's costing them. So you need to be aware of that. Give your users choices about whether to only do transfers when they're on Wi-Fi, and making sure if you are doing network transfers, you keep it as compact as possible so you're not costing them money. And think about caching data, and think about the startup experience of your app. You know, the last thing anybody wants to see is they start up an app and the first thing they have to do is watch a progress bar while we're saying, hang on, we're just getting some data over this really bad network. And that's going to be a bad user experience. So think about these things and make sure that you're being a good citizen and giving your users a good experience. We've got some capabilities which are relevant. I'll just mention these up front. On Windows, there are 3 different flavors of it. The Internet Client, which is required for outbound traffic, Internet Client and Server, which is peer-to-peer, and then private networks when you're on a private home or work network. Those are all rolled into one on Windows Phone 8.1. It's just Internet Client and Server. So if you need to use a network, just make sure that you've requested that capability. And when you're thinking about building in networking capability in your apps, don't kind of reinvent the wheel. Don't go right down to the bits and bytes unless you really need to, because there are lots of higher level frameworks and abstractions you can use that make your life much easier. And Azure Mobile Services are going to look at in a moment to easily build a cloud backend. And Azure Notification Hubs makes it really easy to send notifications from backend services to multi-vendor clients. So not only our clients, but also to iOS and Android devices and to web clients as well. It makes it really, really easy. So use these services. And the background transfer service for download and upload of files, which we're going to have a quick look at. Web Authentication Broker is a great component we're giving you in this release, which makes it easy to do OAuth 2 authentication against internet social networks. And the HTTP client is there, and it's a really rich API for when you need to make those direct calls. This is a complicated table of all of the different APIs we've got. I just want to call out a few things there. We've got HTTP web request and HTTP client. HTTP client there's 2 flavors of it, system.net and windows.web. The windows.web one is the one you want to use. It's better than the system.net, which is the kind of older, now almost deprecated, if you like, .NET API. And we've got a couple of convenience APIs, Syndication Client and Atom Pub Client, which make it easy to read content from those kind of sources. And then when you look down to the web services, there's one big thing you have to call out here, is that WCF Windows Communication Foundation APIs are not supported in WinRT apps, Windows Runtime Phone apps. They are on Windows Store apps for big Windows, but they didn't make it into Windows Phone. So it was one of those features that, yeah, sure, we'd love to have put it in, but had to be cut in order to hit the ship date. So if you have already got legacy, you've got WCF services out there that you want to access from a WinRT app. So just be clear about this. You can still access them fine from a Windows Phone Silverlight app. But if you want to build a Windows Phone WinRT app, you need to access legacy WCF services. Then you might have to think of putting a REST service facade out there, which acts as a gateway that you can call first, and that in turn makes the call onto your WCF services. So those are the APIs. Okay, now the first kind of proper topic, if you like, of this after the intro is I want to have a good look at Azure Mobile Services. Well, actually a very brief look, because again, this is one topic that you could easily spend a whole jumpstart on. It's a really cool system, but I'm going to introduce you to it, just in case for those of you who haven't come across it before. What is it? It allows you to easily build and host a mobile backend in the cloud. And it's completely cross-platform. So we support iOS, Android, HTML5 clients, just as well as we do Windows and Windows Phone. The code backend, your scripts in the cloud, it can be in C# or it can be in Node.js. And it's got great support for push notifications. We've got enterprise single sign-on. You can authenticate against social networks such as Facebook, Twitter, or Google. And your backend database, so behind all this there'll be some kind of a database. That can be SQL Azure, or it can be Oracle, SAP, MongoDB. You can scale it out to millions of devices. This is a proper cloud service. It actually comes with an enterprise-grade service level agreement. It's a really, really cool offering that you can use to build out your backend. So they've got great tools in Visual Studio 2013, which you can use to create the Azure Mobile Service. Now, you can go to the Microsoft Azure portal, which is at manage.windowsazure.com. You need to sign up for a Windows Azure subscription. And you can create all your services in there, obviously. You can do all the stuff that you like in the Azure portal. But there's now great tools built into Visual Studio that help you to do a lot of that work from within the dev tool. So you can right-click on your project and say Add Connected Service, and then this puts up this dialog. I'm going to show you this in a minute, so I'm not going to talk through this too much. And this allows you to create or connect to an existing Azure Mobile Service and create a new one here. And it adds all the correct references to your project and plugs some code into your solution so it's ready to go to connect up to that new cloud service. And from within the Server Explorer in Visual Studio, you can go and look at your tables and create new tables up in the cloud, and you can edit the scripts, because it creates some scripts that are associated with each of the CRUD operations: create, read, update, delete. And you can edit those, whether they're Node.js or .NET, C#. You can edit those directly from Visual Studio. So you've really got great control right from within Visual Studio for all of these operations. And then you just write some code to interact with it. So it gives you a client object. At the top line of this method, where it says iMobile service table to do item, to do table equals app.taskmaster demo client. That taskmaster demo client is an object that when you subscribe to the service, it added to your app class, which is a proxy class you use for interacting with your mobile service up in the cloud. And you can create objects in your own code and then simply insert them into a table. And we're going to do all that in the demo. You can also really easily configure the whole thing up for push notifications and do all of the steps you need to do both on the client side and the client app, and also configuring the backend service. Again, all from Visual Studio, so it's very, very powerful. Now, before I go to the demo, that is just the slimmest little touch of what you can do with it, because Azure Mobile Services, You can really easily add authentication. So, and this is important, obviously, if you're storing all the data in the cloud from all of your clients, and hopefully you've got thousands of clients running your app, you need to separate each client's data. So they need to authenticate, and then you can actually record against each object that gets created up in your tables in the cloud who actually owned, who created that object. So you're partitioning that data by user. You can customize the scripts that are associated with create, read, update, delete. You can implement scheduled background tasks running in the cloud, so that you can have some background logic that's running frequently and can be looking at doing some back-end processing and looking for things that are relevant to your application scenario. But almost the most important point is, up till now, everything has had to be online, which for me has been, well, it's interesting, but like I said at the beginning, in the real world, with connectivity not guaranteed, an online-only solution is only of limited interest to me. But now they are bringing out, it's still in it's only early adopters, so this is a preview at the moment. They're looking at offline support. Demos are out there for Windows clients at the moment. You can go and search for them on the web for offline support, and that will be coming for Windows Phone 8.1 in the near future. Now this is really cool because this means that we've got a SQL-like database on the client, and when you pull data down from the cloud, it's stored in that database, it's cached, and thereafter your client app can carry on working against that cached data, which allows it to work offline. And then when you get a connection again, you push those changes back to the cloud and you're connected again. This is really cool, and this makes it...
It's so cool. It's really exciting.
Okay, let's show you the Visual Studio tools, how this works. This is the portal, by the way, to start with, the Azure Mobile Services portal, where you can create mobile services. I could go down here and I could create myself a new mobile service, but I'm going to work in Visual Studio. Now I've got an app here. I'm going to run it first. It's not hooked into the cloud at all. It's just a dumb client, if you like. This homepage actually will show a list of tasks that you've entered into this Taskmaster app. And when you hit the plus on the app bar, it takes you to a new page, and you can put some stuff in. You say something like, this doesn't work yet, or something like that. So we do that, and then you can assign it to Andy. Let's go to that keyboard. It's kind of annoying. Down. There you are. Thank you. And then you can save it. Except save doesn't actually do anything at the moment because we haven't put the logic in. And there's no tasks. So okay, that's the deal. Now I have to know, obviously the app kind of understands tasks, and in my data model I've got a class called task item. These are the objects I'm going to work with in this app, and we've got 5 properties on this object. ID column, we've got a title, description, due date assigned to. Those were the entry fields, data entry fields you saw on the page there when I was trying to enter a task. This is our model that we want to store in the cloud. Okay, let's get going with this, and let's start connecting this and build ourselves a mobile service. So I'm going to right-click on the project up here and go down to Add, and in the Add menu, there's Connected Service. So this is going to bring up the wizard, the Services Manager. Now, ignore Jumpstart to Do Live there. That actually one I created 18 months ago in the Windows Phone 8 Jumpstart, when I did a preview of Azure Mobile Services, which was just coming out at that time. So that's a really old one. I want a new service, please. I'm going to choose, I've got 2 subscriptions to choose from. I'm going to create, this one is going to be called Jumpstart Demo. .azuremobile.net. The runtime is whether I want .NET Framework on the back end or JavaScript. I'm going to choose JavaScript. Region, let's create it in North Europe. This is where it's going to be hosted in Azure. And I've already got a database. I've created a SQL Azure database. So I'm going to use that one. I'm going to put in my password for that. And it's creating that service. and we wait a minute. This is just the same as if you did it through the portal. So it's building it in the cloud at this moment. It's hooking up the database schema. It's creating some REST services for this service up in the cloud and spinning up the kind of web worker roles. All this is a package solution. You could build all the bits of this yourself out of in Azure if you really needed to. But that's why this is kind of a software package as a service kind of thing. It's a ready to go back-end mobile service you can use for your apps. Still chuntering away. It will take a few seconds. It always does, and it's taking a bit longer than I feel comfortable about. Come on. And then, so it's building this out in the cloud, and in a minute, wait, there we go. We've got our service has been created. Now, when I hit OK, it's adding it into my solutions. And now this is where it's integrating my client app, this app already. Now, what has it done? It's added some references. So we've now got some references for Microsoft at Windows Azure.mobile and at Windows Azure.mobile.ext, and it's added some other stuff for HTTP extensions. So we've got some new class references, and it's also added into my app.xaml.cs some code. It's added in this. This is my proxy object, which I use for, this one is going to be my object I'm going to use to interact with this service. And it's also already hooked up the address of my service out in the cloud, and this is the key, the client ID that you need to specify. So it's already done all that kind of stuff for you. Now, we go over to this Server Explorer here, and here's Windows Azure. We can expand this out. You see mobile services here. You can actually go into look at everything that's in Azure. And there's my old service, and any of your services will be listed here. So this is my Jumpstart demo one. There's nothing actually in it yet. It's just an empty service. So what we're going to do in here is create ourselves our first table. So I'm creating a table. I'm going to call it task item, which spookily is the same name, of course, as my model that I've already created in my project, the task item.cs I showed you before. So create that table. It's creating that up in the cloud. And when that has created, it's off to the cloud. Now, again, you can do all this in the portal. Now it's refreshing in Server Explorer. And now we've got our table. And if you expand that out, here are the scripts which are, for example, on an insert, we've got this JavaScript, which is pulling down now from the cloud, which actually just simply, there's no code in here at the moment, just executes that request. You can customize these in Visual Studio, but we're not going to. We're just going to leave it like this. Now, actually, one thing, I will just go over to the portal. I want to show you something. So here's now my new service has just been put on here. We can go off and look at the data in the portal. And we've got this task item table that we've just created. If we look at the bit more detail of it, obviously it's got no data in it at the minute, but the columns it's got in it, it's got 4 columns that it's created for a new table. First of all, it's got a primary key called ID, which obviously is really important to identify each record in the table uniquely. And then it's got 3 columns: created at, updated at, and version. These are versioning columns, the metadata, if you like, that it's already put in, which is to support all the data synchronization, the offline working that I was talking about. That's why those are there. So don't delete them. They're important. They're used by the framework. But you'll notice we've got ID, but remember how this object has got all these other... Sure, we've got an ID column in our objects we want to store up there, but we've got these other ones: title, description, due date, and assigned to. How do we get those into our table in the cloud? Well, this is one of the really cool things about Azure Mobile Services. And during development, it has this idea of a dynamic schema. So all we need to do is to get one of these objects and serialize it to JSON, send it up to our service, and the Azure Mobile Service will automatically configure that table, add columns to it to dynamically expand the schema to support whatever you send at it. Does mean you don't want to send any rubbish up at it, of course, as well. But this is really cool. So that's what we're going to do. So let's add some code now to the project in order to do that. Go over to main page. This is our main page, which shows the list of objects. So I'm going to put in a little snippet of some code that I've already got for this, which is JMS get tasks. There we go, get task items. What we're doing is we're going to call our jumps. This is the object that it created for us. We're going to get the task item table. We're going to get all the items that are in it, and that will return us a list of task item. And then what we're going to do with that list is put that as the item source of a list view, which is the list of objects on our main page. And of course, we need to call that from somewhere. Let's go into, well, let's put it into navigation helper load state. Let's put it into there, which runs when we come into that page. So I'm going to call that new method that I've just added, get task items in there. Now, of course, the first time we run that, there won't be anything, but now we're hooked into the cloud. We're going to pull items down and display them on the screen. So the next thing I want to do is actually put the logic into insert into the cloud when we create a new task item. So when that plus button on the app bar is hit, which at the moment it didn't do anything. The reason why it didn't do anything in it because we haven't got any logic in it. So let's fix that. First of all, let's add another method here. Now this is going to insert task items. So I need to fix up some references. Into Azure Mobile Services, and now we can call that when we're on the save button here. So we can say await, which I'm going to call an await function. So let's put async on there. And there we go. Await. Insert task item. And that's going to insert it into the cloud, that method and then we also need to go back, frame.goback, having done that. All right, so now we can run this and see if it works. No tasks come back, but let's add one now. Azure Mobile Services rocks. Oh yes, it does. And yeah, due date, and we'll assign it to me, and we're going to add it, and there it is, and it's gone. It's up in the cloud. How do I know that? Well, let's just prove the point. It's browse up in the cloud, and there we go. AMS rocks. Oh yes, so it's up in the cloud. So that's how you add a record, add stuff into there. Now, the next thing we can do is, so that's pretty cool, that's good starters. And what about adding some push notifications to this as well? So we go add push notification. So we get a big window. It says, before you begin, it just tells you what it's going to do. It's going to associate the app with the Windows Store. Now you can do all this with, directly from Visual Studio, but it's going to do that for you. It's going to add some code to the project for sending the push notification channel URI up to Azure Mobile Services. It will modify the back end to enable it to send push notifications through WNS, and it will do some stuff with redirect domain URIs. So let's just go ahead and do that. Now I have to sign into the store, so I have to sign in with my Microsoft account, which is this one. And add in my password. And then sign in. Now, at this point, it's going to email me a link, or you can send it by a text message. So I'm going to send it to, this is like two-factor authentication. So it'll send it to an account, and somewhere I've on my tablet here, I'm going to wait for this to come in. It's come, oh no, that's my climbing, Super Topo climbing news. Just got a new email. It's not the one I wanted. We're waiting for the new one to come in. Come on, baby. Come on. We might have to come back to this.
You're a braver man than I. I have this.
What, email? Yeah, well, I did try this morning, and it did work like, bang, it was straight in.
Yeah, no. I've had the code come in very quickly, but when doing demos, I'm always so nervous about two-factor and...
yeah, I know.
Wow.
Yeah, well... Yeah, we're still waiting. Oh, it's coming. Thank you. So I need to open it. Right. So I've got a code which is 3288. Read this 4841. So we've authenticated. It says, yeah, you are who you say you are. It's checking the developer account. And now this is how you associate your app with the store, which you're going to have to do anyway before you publish any app. There's some apps I created, lots of cocktails apps. You can create a new app name, or we can use one that we reserved before. I'm going to use one I reserved before, and nobody else has got Jumpstart Demo 001. And now it's find out what services you've got. Which one do you want to use? So yes, let's do the one we just created. So you go next. Now it's going to tell us what it's going to do. It's going to add some more references, add some more code, and update the mobile service. So let's let it do that. It's doing loads of cool stuff. It's setting up push notifications in the cloud. It says this may take several minutes to complete. I sincerely hope not. And it's creating a custom API which allows you to call push notifications as well. Yeah, there we go. So what it's showing us here is actually it's showing us in Server Explorer. It's added a new script, notify all users.js, which is on the server side, and this has got a function you can call to send a notification. And the default is just to send a little hello world notification. And it will do that. Actually, also it's added a class into my client side app. This is in the mobile app. It's a method called upload channel, which registers your app with push notifications, gets the channel ID, and then sends that channel ID up to the cloud, which registers your client with the push notifications on the back end. And then it also, just for good measure, just to show it all works, it invokes that custom function. So we should get a toast coming back through a WNS when this has all happened, just as a verification to us, a confirmation that it's worked. So, and the other thing, of course, it's done is it calls that method. It's stuck another line on the end of my onLaunched, hopefully. Yeah, there we go. It's stuck that in as well. It's calling Taskmaster Jumpstart Demo Push upload channel, which is that function I just showed you, which is added to the project. So if we do that, when it launches, it will register for push notifications and send its channel ID up to the cloud. In a minute, we'll get our list of notifications down from Azure Mobile Services again. Yes, there we are. That's the one I entered before. And it's also got a push notification channel, which is sent up to the cloud. And we should get a notification in a minute, which will say hello world, just confirmation that has all happened. Go on, don't let me down. So that's still thinking about stuff. Okay, and then it didn't work because the timeout period expired. It was trying to send it up to the cloud, and every time I have tried this before, it has worked. But now, live in front of the cameras, it's let me down. Thank you. Okay, well, I haven't got time. We might try it again later, but trust me, you obviously need some try-catch around that. There's the message of that in order to handle this in a real app. But if you do this, it is reliable and does work. So, but I'm going to move on because we've got too much to talk about. All right, that was a quick intro. Loads more stuff you can do with Azure Mobile Services, of course. So have a look at it. It's a really cool way of building out your mobile backend. And like I said, it is cross-vendor as well, so you can support if you're building a mobile solution with different kinds of devices on it. Android, iOS as well. Yeah, we can support them. And
there are sample projects for everything under the sun. Website, iOS, Xamarin, Android, everything. They're just kind of like, hey, use our service. Here's a pile of code.
Yeah, they do a really great job of step-by-step tutorials to help you do all kinds of, and it's much more sophisticated than that trivial little demo.
It's fun and it's almost magic when you try it the first time. So. Yeah.
Right, a quick look at background transfer service, because again, in the idea of abstraction, mobile services that, things that make life easier for you as an app developer, if you want to send a file to the back end or upload a file from your back end servers, this is the way to go. You could write some code at HTTP client and handle it all yourself, but why bother? This is given to you on a plate. It's a power and cost-friendly API for doing that sort of thing. It allows you to do parallel or serial file transfers. You can have transfer groups. It's also got some nice features for updating tiles and sending toasts when a transfer is completed. So you can just set properties to do that. You don't have to write any code to do it. And it also, the cool thing is it actually knows all about expensive networks and will automatically switch to cheap networks. And so it's kind of cost-friendly as well. easy to use. So this code here, the actually important bit is there's a couple of things in here. So reading down from the top, first of all, we create ourselves a cancellation token source. This is something you use with async long-running operations to cause a cancellation of it from your foreground app. And then we have a storage file, destination file. We're using the known folders to get us a file from the pictures library. This is just an example of something you could send, okay? Now, we new up a background downloader object. And then on that object, you call the create download method on it, which gives you back a download operation object. And then you just call download.start async. Which starts the operation. This special form of it with .as task allows you to send in that cancellation token source, which makes it cancelable from your foreground app. If you don't have that, it's just fire and forget. Let it get on with it. And then there's also, you can have a progress callback. So those last two bits of it are entirely, the .as task is entirely optional. You can just set it off and then away it goes. And then you will get your task cancelled exception or exception if the user cancels it. So that's the kind of the deal. If you cancel it, well, you just call the cancellation token source.cancel and then dispose of it. So you might put that on a button in a foreground app to say, okay, cancel that. But the key thing, of course, is this is all happening in the background, and if you want to get some progress reports from this thing that's going on in the background, download progress is an event handler for getting progress reports from it. But you don't have to have the foreground app running. You can have it. The foreground app could be suspended, and the OS will just take care of completing that background transfer for you. I'm going to show you a very, very quick little demo of this. Get the right key. Right, there we go. And actually, what this demo is it's actually the SDK sample, because and I've got two motives for this, because I wanted to show you one of these samples because they are universal. Just to drill home the fact that all this stuff works on both Windows and Windows Phone. You get a Windows head and a Windows Phone head in it, and then in the shared area is basically all of the stuff, all the logic. So there's download, upload, and notifications. The download one is basically kind of a more extensive version of what I showed you there. But the important thing is this one. Let's go to that method, go to the definition of that. This is where we actually set a progress callback, and then we call that download.start async on our downloader. That starts it. Or you can if you run up your foreground app and there's a downloader already going, you can attach to it, so you can enumerate the background tasks that are running. Two little quick examples of that. First of all, file download, and just look at this wonderful UI. Somebody didn't do a really great job on this, I'm afraid. Look, this is pretty horrible. Buttons extending off the end. This is because this was a quick port from the Windows version. Just to show you that you need different UI on a phone compared to Windows. But we've got, what's this? This is where our background service is. Background transfer sample. It's a website running on the in IIS. If I just go over to IIS Manager. Go and have a look at my Internet Explorer IIS on here. Default website. Here's my background transfer sample. It's running on my dev box. So what's weird about this?
It's the local host. You're not calling out to an external service.
No. Those of you who have ever built anything networking for... there we go. I'm just going to let that run. It's running in the background. We're getting progress reports. Yeah, anybody who's done anything in Windows Phone 8 will know that you cannot call a local host service from an app running in the emulator and get it to work out of the box. No, it'll never work.
Right.
It'll never work. You've got to have the host name. You've got to open firewalls. You've got to do all sorts of security stuff.
It is a task and a half.
It is. It's documented, but it's not fun. That's completed, by the way. and while we're at it, I'm going to show you this completion notification. You can do cancel. You can do 3 downloads from previous. So we can start 3 downloads and show toast on completion, and that will start 3 different downloads from our website running in my IIS, and then we'll get a toast when it's done. Yeah. So the localhost is really cool because it means it's super easy now to create anything that's connecting to a service. Have the service running on your dev box and test out the app running in the emulator, and it all just works. It's so cool. And we should why is this not? Oh, I must have hit a breakpoint. That's why it's not running. Oh no. Is it? What's going on?
So did you check the Action Center? Because the toast might not pop up if you're in the foreground.
All 3 downloads completed. Ah, thank you so much.
No problem.
Yes.
We'll cover that in the next session.
Yeah. Actually, I want to show you one other cool thing in the external tools here. Look, on the network tab, we can simulate different quality. Oh yeah, it does come at the bottom. There you are.
Okay.
I knew it did something. 3 down, and we got the toast comes up. Yeah, it was just slow. Then you can simulate different network speeds. So we can go 3G. We can simulate. It's because I meant to uncheck that. I was actually on a 3G network. That was why. So it was kind of slow. And if I do it much quicker, you turn off the network simulation and run it. It goes pretty quickly, like at warp speed. Yeah, there we go. So, but yeah, you can turn on the network simulation and do it again. And actually, before I do it, let's put this back into normal orientation because that's making me feel seasick. Start another 3 downloads, and then obviously we can come out of the app. We can even suspend it. Like, terminate it. Let's terminate it. And chuntering away in the background, the backward transfer service will still be doing its thing, and we should get a toast come up in a short while. Did it come up already? Oh, I think it might have done, because we've got 4 of these guys now. I don't want to see that date time thing anymore. So the background service is still running. Would still run in the background, even though the foreground app has been terminated. All right, moving swiftly on. HTTP client. This is one of those APIs that it's super simple to use and also super flexible, so you can get it as complicated with it as you like. This is where you actually need to make HTTP calls to maybe to a REST service. You're not using the beauty of Azure Mobile Services or something like that, so you haven't got a proxy object. You need to get down and dirty and code right down, craft your HTTP request yourself. This is the simple way of doing it. You new up an HTTP client. You can set some request headers. This is really nice. There's this strongly typed request headers now. So you can do HTTP client.default request headers.accept, or all the kind of other headers as well. .try parse add, and it will check that the string you're passing in is appropriate for that header. So that's a nice way of avoiding errors in setting headers. And then you can, if you want to get a string, like it's a service that returns JSON or XML or something, you can just call http client.getStringAsync. That's it. That's as simple as it is. We have got, I mentioned this before, there are 2 HTTP clients. The old one is system.net.http client, which was the only one available in Windows 8.0, and it is also available through NuGet packages for Windows Phone 8 and actually for Windows Phone 7 as well. It wasn't in the Windows Phone 8 SDK. But that one is a kind of .NET API. There's nothing wrong with it. It's it's fully tested and works and it's great. But the better one is the windows.web.http, which is the Windows Runtime API. So just make sure when you're using it, you resolve to the right type. And we recommend, in most cases, you're going to want to use windows.web.http. In simple usage, like getStringAsync, they're the same, but as soon as you get more complicated, their usage differs somewhat. If you want to go or get a bit more complex, and you want to get the full response, instead of getStringAsync, you call getAsync, and you'll get back an HTTP response message. And that allows you to go in and look at headers and status codes and get the stream of the content, or get the here we've got an example of getting the text with response.content.reader string async. But it allows you to get at much more details and information about that request than you can with the simpler usage. Loads of better information on that. Here's an example of reading the response headers. So you call client.getAsync, and then for each header in response.headers, well, we're just dumping it out in a text file here, but you can have a look at the response headers to get a bit more information about what's coming back. And when you're on sending out, you can write out request headers. We already saw an example of this with the try parse add for a strongly typed header, but this is the full list. So, accept encoding, accept language, you can read the full list there. I'm not going to read down them all. So all of these, this is the new way. They're strongly typed header properties that help you make sure you get the syntax right for setting these things. Actually, I'm gonna skip this. It's in the downloaded code that you can download because I just want to keep moving to try and keep on schedule. Because I want to move on. Oh, just before I move on from HTTP client, I showed you some fairly simple stuff here, but actually it is a whole pipeline, and you can plug code into different bits of it. So retry filters, those purple blocks in the middle are modules that you can code yourself and plug into that HTTP client pipeline. You can put those orange, purple ones are filters that you can put into the pipeline. The one on the right in the grey box, the HTTP base protocol filter, that is also a filter, and it's one that's given to you. And this one is actually how you turn on compression. Please do this. Always do this. There is no reason for not doing this. If you don't do this, this is one of those things where you are being a bad citizen. You're creating an app that's not being friendly to your users. If you're pulling stuff over the network, make sure that you say to the server, I accept compressed content, which is how you do it here. HTTP base protocol filter. You set the .automatic decompression property on that to true. That means you're saying to the server, yeah, I do compression stuff. It will, if the server supports it, which it may not, it will then compress the content and send it to you compressed. And then, as it says, it will automatically decompress it on receipt. So that means you're sending less stuff over the wire. Putting credentials onto it as well. Here's a password credential object. You can set that and put that onto the server credential or proxy credential properties of your HTTP base protocol filter object. And then, to use it, when you new up your HTTP client, just pop that into the constructor. And away you go. And this all ties into this subject of making smart decisions about data transfer. You know, just to drill home, I know I've said this a few times, but mobile devices work on bad networks. You know, it does. It's a fact of life. So you want to be aware of this, use compression, and also think about the amount of data that you're transferring. And actually, whether your data comes over as XML or JSON makes a big difference for that as well. So and don't transfer redundant data. So if you've got a service and you only need some data on the client, don't be lazy and send loads of stuff the client doesn't need. Send a nicely tuned package of information that's only what it needs and no more. I've got a nice demo that drills this home. It's a favourite of mine. I've used it before, and I apologise if you've seen it, but it's too good not to use again. So I'm going to open the solution for this. And what this is it's a service. So viewing the browser, it's actually a WCF data service. And this is the root of it. It's our old favorite, the Northwind database. So this is OData. So you can navigate just by going into, changing the URI. So we can go into customers, and it will give you a whole list of all the customers. You can get a particular customer by, again, changing the URI. So let's get the third customer. And also, oh, that wasn't what I expected. What happened there? Customers. It's because it's not it's actually a keyed thing. So if we want to get a particular customer, we go dash, let's get ANATR. There we go. And you can also, and there's all these cross-reference stuff into it. So if you want to find out the orders for that particular customer, you see this href there, you can actually kind of, tells you how to change the URL in order to navigate through the relationships in the database. So it's super flexible, really good for clients to be able to dynamically navigate through relational data. So that's our service. But over on the client, now I'm just going to run it. It's a boring UI. but it's going to call. The interesting thing about an OData service like that is you can get the data in different ways just by setting request headers. Say, okay, I'm cool with Atom, or I want it in JSON. So first of all, let's do the OData Atom, and it's hit a breakpoint. It's made a call using our friend HTTP client, get string async off to our local host on port 1494. Oh yes, that's so beautiful. And we've got our payload. If we look at the payload, it's actually all that Atom feed XML we just saw in the browser. There we go. So that's all the data. And I'm interested in the size of it. So I've just popping up a message box. As you notice, this is a Silverlight 8.1 app. Received a payload 28K, so that's the first one. Do it a different way. We call the same service, but actually we've put this application data, JSON, OData equals verbose header on it. So this time, it's coming back as JSON, but it's the verbose format, so we've still got all that cross-reference stuff so we can navigate the collection, which is nice, or might be nice. But the size of it is 15.4, so it's a bit smaller than the Atom feed. But now we can send application JSON, but not the verbose form of it. And this one is 8,000. This is the same data. We're just getting the supplier's data from the database. It's exactly the same data, although this now doesn't have the cross-reference stuff. And the final one, hitting the right button, is the same thing, but I've actually zipped it on the server just for effect so that we can see. That's what it kind of looks like. And that one is 4K for the same supplier's data.
Is that JSON or XML?
That's JSON, but also using compression on the wire.
Oh,
so it's
okay,
compression
okay.
and JSON REST.
Okay.
And just to drive home, if we, just to drive this home, if we go on a 2G poor quality network, because this is really a very small amount of data, and to count the seconds now on this really poor quality network to do the most compact thing, we go 1, 2, it was about 2 seconds, okay? And now do the other one. 1, 2, 3, 4, 5, 6 seconds. And that's a tiny amount of data. So that just really drills home to you the importance of using the right format on the wire.
That is a great demo.
It's nice, isn't it? Yeah. So that's just a confirmation of that. Wire serialization format makes a big difference. In network awareness in your apps, again, there's lots of APIs that help you to find out information about the network. First of all, you can get information through the network information.get internet connection profile call. That gives you back a connection profile object. First thing you need to do whenever calling it is check if it's null. If it's null, you're not connected to the internet. So that means you've got no network. And then you can also, there's lots of properties on it. So you can find out whether you're on wireless LAN, is WLAN connection profile. You can find out if you're on data roaming. So then if the internet connection profile is W1 connection profile, that means we're on a cellular network. And then you can drill down. I'm looking at the middle method here, and you can go and get the connection cost, the internet connection profile.get connection cost, and that object has a roaming property on it. So you can find out whether you're currently roaming. So this is good for making good decisions about being kind to your user, not trying to do big data transfers when you're on a roaming network. And there's also the network information.network status changed event, which you can show at the bottom. You can hook that and get an event firing when the network status changed. So again, you kind of hook that event and then do these other calls to find out a bit more information about the network you're currently connected to. What does this tie into? Well, there's this thing called DataSense, which is a set of components designed to help both your end users minimize their bills, helps mobile operators reduce their consumption and connectivity, and helps third-party developers build smart data-consuming applications. It's a whole suite of stuff. There's apps in it which the end users can use for looking at which apps are the hungriest and have transferred the most data. So again, another reason for keeping your data transfers compact, because if you don't, your users will see it and they might uninstall your app. And it's also a browser optimization service. So there's a kind of proxy that will send compressed content when you use the browser. Wi-Fi hotspot mapping to help users connect to cheap free Wi-Fi services. And part of that also is you as a third-party app developer can build data-smart applications. There are three kind of scenarios: the content streaming app, where it's a bit like Netflix or Hulu, where you've got content streaming all the time. A file sharing app, well, OneDrive or Dropbox, but actually the background file transfer service is probably a better way of kind of transferring files. And then a Wi-Fi only app, where you want to allow your user to do some syncing or something, but only when you're on Wi-Fi, not when you're on a cellular connection. I'm just going to look at the first one of them, which is the content streaming scenario. Again, it's our network information.get internet connection profile API. You need to find out, are we on a wireless LAN? So you call if internet connection profile.is WLAN connection profile. And then, if it is, you can get the connection cost of that profile. Find out check it's an unrestricted network cost, and if all that is true, we know we're on a free Wi-Fi, and hey, you just go away and stream away, and it's going to be good for your users. If you're not, if you're on a wireless WAN connection profile, then you're on cellular data, well, then you might want to put up a prompt to the user, say, do I really want to do this? So this is about being good to your users. This is the W1. Here you want to check, going on from where we were on the previous slide, get the connection cost. Look at the network cost type. If it's a fixed network cost type, then you can look at these ones at the bottom if statement there. If it's over the data limit, this is where you've got the data smart is activated. If it's over the data limit or approaching the data limit, then you know that they're close to exceeding their data allocation on their data plan. So then you want to say, okay, I'm sorry, you haven't got enough you haven't got enough capacity left on your data plan. I can't do what you want. You need to connect to a free Wi-Fi service. So it's all about information and being good to your users. Right, I'm going to wrap up with identity and authentication. I'm going to keep this short, although it's an interesting topic. The thing about identity and authentication is a lot of apps need it. It's if you've got a third-party app, a lot of them you can just run them and apps run and they don't need to know who you are. But as soon as you get into the idea of allowing people to personalize the alerts that they want to see, like that football, soccer, whatever. If you want to know, Manchester United's your team, you want to get alerts when anything happens to Manchester United, well, sure. Then your back-end service needs to know who you are. That means you've got to sign in. You need to have authentication. So a lot of apps need it. But the paradox of all of this is that obviously users don't like signing on. And if they do have to sign on, you want them to sign on once, and then your app needs to remember it. So you're not asking them to sign on every time that they run up the app. So this is what you need to do. And there's certain APIs in Windows Phone 8.1 that help you to handle this situation. First of all, a little bit of secure storage. I'm just briefly going to mention this because we talked about this yesterday in the data session. But the Credential Locker API is if you need to store credentials on the phone in local storage, this is what you need to use. And we already covered this in session 9 data, so I'm not going to say too much more about it. It is secure. It secures they're secured from other apps, and the best thing is as well they roam. So if you have the same app running on different devices, they can these credentials are stored once on one, and they're available to where your app is running on the tablet or on another device. This is the API. You new up a password vault object, and then you store in that password vault password credential objects, and to get them out you can new up your password vault, and you interrogate there's various methods for pulling them out of there. We covered that before, so I'm not going to say anything more about it. I want to say a bit more about this though, the Web Authentication Broker. This is a component that really takes the pain out of authenticating against services that need OAuth 2 authentication, such as Facebook, Twitter, and a good number of others. Many apps you need to connect to these online service providers for doing social networking kind of features. So you're using their REST APIs to interact directly with their services. But the other thing about this actually for users, even if your app needs to store my soccer app, you want people to authenticate in some way, we could have our own authentication service and make users log on to that. But that would just be yet another username and password that user has to remember. And you know how it is. You have half a dozen of these things. And you can never remember what the password is. Or you use the same password on all of them, which is kind of defeating the purpose of things. much better, unless you really need to have strong authentication for a security point of view, is if you simply want to know who the user is in a unique kind of way, allow them to authenticate against a social network and give them a choice. Say, okay, you can authenticate against Twitter or Facebook, or which are services they use consistently. They authenticate against them, and you're just kind of borrowing their authentication service as a way of identifying users for your service. Then you can send their Twitter username or something back to your service and store your personalization settings against that. So the typical OAuth flow is you've got your online service, the app makes the authorization request, then the online service will pop up a web page with a username and password. The user has to authenticate against that, enter their credentials. Then the user decision goes back to the online service. The online service authenticates that, says, yeah, you're cool, and it sends back a token to your app. And thereafter, the app uses that token whenever they want to call back into that service. It's complicated to implement, and you have to have an embedded web browser control, which we don't want to do all of that. It's hard to implement, and it's got a lot of other problems as well. The solution is the Web Authentication Broker, where you can authenticate easily and support single sign-on, which we're not going to cover. We'll cover that in the enterprise session this afternoon. It's very simple to use, and what we've effectively done is taken all of that bit and stuck it into a component. So the way you use it is just actually, well, the way on the left, again, this is one that differs between big Windows and Windows Phone. So on big Windows, you new up your web, you just call web authentication broker.authenticate or async, and you wait for that. It's an awaitable method, and then you handle the response, you look at the response. And then there's a get token method. On Windows Phone, it's one of these and continue methods. You call web authentication broker.authenticate and continue, and at that point, your app suspends. And we transfer control over to the shell component, which handles the authentication for you. And then when the authentication process has completed, it will reactivate your app, and you need to handle that reactivation, which you do like this. In the onActivated method in your app.xaml.cs, you'll be looking at the args that have come in and say, is this a web authentication broker continuation event args? Takes a deep breath. If it is, then first of all, we got that standard logic, which is all the rest of this page is standard stuff that you tend to have on all of these activated events. This is where it gets interesting. You then redirect at the bottom. You navigate to the type of my page where you made the call. Whatever my page that does auth is the one that made the call to the web authentication broker in the first place, where the and continue method was. So you want to navigate back to it, and then you need to pass that web authentication broker continuation event args object that was sent in over to that page, so it can look at the response to find out whether it actually worked or not. On the page where it happens, you've got that property which we've called continuation args, which is of the same type as that activation event args. And in there, you would, in the setter, as we've shown here, you would call some code that continues, picks up exactly where we were with the Windows after that calling the async method. So at this point, you look at the web.authentication result to figure out whether the authentication was successful or not. Okay, a very quick demo for this. I've got in here, I've actually got, again, the SDK sample, which I'm not going to show, which has got really cool code for how you use this to authenticate and call services for Facebook, LinkedIn, Twitter, Flickr, loads of stuff. But I'm just going to run my own just to give you experience, show the experience of it. I think we're done with all that kind of stuff. The main page, it calls authenticate. Let's just look at the code behind that. Button click calls this authenticate method. Go to the definition of that. This is it. We've got some, I've already been to Twitter, dev.twitter.com, and I've got myself a client ID and an API secret, which I defined further up in in statics. And then you have to give it some URIs, which again I've registered up when I went to dev.twitter.com. But then all you need to do is call this authenticate and continue method. So let's just go ahead and do that. And after that, it will suspend my app. Have I not got a network or something? What's going on here?
Are you still on the 2G network that...
Oh, man. You're so... Right.
There we go.
Let's just do that again. Thank you so much. I was thinking, what? Okay. It's really super powerful, that, isn't it? And it kind of gets in your way sometimes. Are we actually... anything happening here?
Authenticate, yeah.
Doesn't look like it, does it? No.
Yeah.
Yeah.
Okay.
Yeah. And then... oh, okay. Well, there you go. This has failed with a unauthorized response to unauthorized.
Oh.
Oh, okay. Well, I don't know. It's the way on that one. I shall have to... We're out of time, so unfortunately I'm not going to sit here and debug this. I will scratch my head a little bit in the break and figure out why that worked. It didn't work. It worked this morning when I tried it out, but there you go. That's the live demo gods for you. So, thank you for that. Yay. Yes, there was... there's always going to be one. Right. There is an SSS mode, which we're going to look at in the enterprise session this afternoon. I'm not going to talk any more about that. So this is cool, particularly for enterprise apps, where you can actually bypass the authentication completely. You've got your own service. It's a really cool way of having a suite of apps share that authentication. Right, so I showed you how to easily build a cloud backend with AMS. I showed you briefly how to use the background transfer API. HTTP client for HTTP networking calls. Briefly mentioned credential locker, and then I failed to demo the web authentication broker. Loads of cool stuff there, and all I can say with that is go and enjoy networking Windows Phone 8.1. All right, we're going to take a little break, and then we're going to the next hot topic is
the best one.
The best one in your view is tiles and notifications and Action Center. So loads of cool stuff in that. We'll see you in a minute.